Hello, good morning. Our dear person is through technical session. Myself, transition. On behalf of Global Knowledge Research Foundation, it is my pleasure to welcome you all to the International Congress on Information and Communication Technology. The 8th edition of this conference is organized in hybrid format. Physical physical is already ended. We are in the digital mode and it's about to end today. And I hope all the participants will enjoy the rest of the sessions. And there's a special note for the presenters that in this session we have 6 presentations, and each presentation will be given 12 minutes presentation and 3 minutes for the question and answers. And on the 10 minutes, I will raise a gentle reminder to conclude your presentation. And there's one special request for all the participants that you may all please connect with us till the closing remarks so we can capture the good memories of this virtual conference. And if you have any query or any update, you can write it to me in the chat box. And just before we get started, I would like to introduce you all to the chair for this session, Dr. Meenakshi Moria and Dr. Gagan. Sorry if I pronounced the name. Okay, just before we started, I would like to give some intro about our short intro about our session chair. If I talk about Dr. Meenakshi Memoria, she did her PhD in computer science from SGVU, Jaipur, Rajasthan. She completed her research on fault tolerance in grid computing. She has 17 plus years of teaching experiences in different academic institutes. Presently, she is in Uttaranchal University as an associate professor, and her research and teaching interests include machine learning, grid computing, theory of computation, compiler design, operating system, intelligent system, data structure, etc. And if I talk about Dr. Galia, she is a lecturer at University of Applied Science, Northwestern Switzerland. From 1999 to 2007, she was a research analyst and project coordinator at the World Bank, private and financial sector, Europe and Central Asia. Western, Washington, D.C., October 2001, and European Parliament and the European Commission, Brussels. Uh, Welcome, both our session chair for to chair the session. Okay, just now I would like to start with the papers. Our first presenter is Lin Ju, and she is going to present on data analysis of video game reviews on Steam.
Hi, everyone. Can you hear
Hello.
me?
Yes, we can hear you.
Okay. I want to show my screen now. Good afternoon, everyone. My name is Lin Zhu. Our team member includes Shu Yaocai, Sun Yizhang. Our instructor is Professor Yanxia Jia. Today, I want to talk about a data analysis of video game reviews on Steam. I'm going to talk about introduction, data, methodology, results, conclusion, and future work. As we all know, video game industry is currently one of the largest in the global market, with over 2 billion users worldwide. The video game industry has consistently grown since at least 2015 and expanded 26% from 2019 to 2021 to a record of $191 billion. It's an extremely popular leisure time activity, especially among children and adolescents. There has been various work addressing the impacts of video games. The dataset used in this paper was published on October 26, 2015. It includes 79,437 game reviews of 11 different video games from the Steam website. This dataset contains 27 columns, including review text, total game hours, number of friends, number of game owned, and rating. There are also 11 games from Steam website, including Arma, Counter-Strike, Football Manager, Dota, and Civilization. First, we want to clean the data. For data preprocessing, we will remove stop words and punctuations, expand abbreviations, and perform stemming, lemmatization, and create diagrams. Because we are interested in the differences between various types of games, therefore, we divide these 11 games into 5 categories based on the categories on the Steam website, namely shooter or first-person shooter, strategy, sandbox or open world, role-playing games, RPG, and sports. We're curious about some interesting topics on video games, and we come up 3 research questions and use different methods to solve them. The first question is, what are the sentiments of the reviews of players for each game categories? To address this, we conduct sentiment analysis, which can help us decipher the mood and emotions embedded in the test. The second question is we are interested in the players who played unusually long hours, that is the outliers. Especially we conduct the exploratory analysis to address the following questions. How those outliers distributed across the 5 game categories? What is the relationship between the total game hours and other attributes of players, such as the number of friends? The last question is what are the main topics of the reviews for each game category? To discover the topics, we use the latent dielectric allocation algorithm and PyDavis to dynamically visualize the topic modeling results for a more intuitive understanding of the results. In order to find out the optimum number of topics, we use the UCI coherence score as a performance matrix. We also found out some very interesting results according to our research questions. This sentiment analysis converts reviews' positive, neutral, or negative attitudes towards the game they're reviewing. Overall, for all 5 game categories, the positive sentiment dominates. We believe this is due to the popularity of all these games. We can also observe from this figure that the strategy and shooter game categories show slightly more positive sentiments. This is also consistent with the other results that I'm talking about. For each game category, we calculate the average of all players' total game hours respectively, as shown in the screen. We can see from the graph, on average, players reported spend significantly more hours on shooter or FPS and strategy games. For outlier analysis, outliers refer to those players who spend extraordinarily long hours playing games. We analyze outliers of total game hours for each game category to see which one attracts the most outliers. The following table shows some descriptive statistics for the dataset, and the box plot shows the distribution of players' total game hours across all game categories. There are 7,056 outliers in total, with the longest total game hours being 16,587.8 hours. We calculate the percentage of outliers within each game category to observe how outliers are distributed in all game categories. As we can show in the screen, from these bar charts, 2 game categories, strategy and shooter or FPS, has a significantly higher percentage of outliers than the other 3 categories. These 2 categories attract considerably more outliers who spend an extraordinarily long hours playing these games. We also found the relationship between total game hours and the number of friends. This figure shown in the screen is the scatter plots of reviews of players total game hours, and number of friends. Both x and y's are normalized values. The value shows a very interesting phenomenon that the outliers in general has fewer friends on Steam. We also performed topic modeling, which shows key topics discovered for each game category. For each game categories, we conduct topic modeling by using the LDA algorithm and Padavis for visualization. We also conducted word clouds to show the most frequent words for each topic. A quick review of 5 categories. There's sports, sandbox or open worlds, RPG, strategy or FPS, and strategy. The word cloud shows the topics for the sports, sandbox or open worlds and RPG categories. And the next figure shows the topics for the shooter or FPS and the strategy categories. It can be observed that the shooter or FPS and the strategy games show a more diverse set of topics than the other 3 categories. Because these 2 categories are very popular, so we focus attention on the strategy and the shooter games. In the shooter game category, topic 0, 4, 5, 6, and 9 are about various features of games. Topic 3 and 7 show that the most reviews of players are enthusiastic to play shooter games. Topic 8 shows that players spend a larger amount of time playing this game happily. One interesting phenomenon worth noting is that the word hours is always followed by a large number, as shown in the following examples. Topic 2 is about player community. Mostly, the reviews say positive things about the community. However, negative comments do occur due to their relatively low frequency. These negative words are not shown in the word clouds, but the Padavis visualization without show in the figure reveals that negative words such as hate and ruin occur mostly in topic 2. In strategy game category, topic 0, 3, 6, and 7 show various features of the game. Topic 1, 2, 4 show the similar feature as shooter or RPG games. Topic 5 contains many negative words within high frequencies, such as lose, win, life, suck, and waste, which shows players' negative emotions. A careful examination of the context of the words life in the reviews reveals that the words room and life are often bounded. The word life frequently appears after ruin, change, and real, but the most frequent situation where life appears is ruin my life. Here shows some example review contain these phrases. Very interestingly, it can be observed that oftentimes reviewers talk about a game ruining their life, where simultaneously they show enthusiasm about the game by either giving it a very high rating.
Sorry to interrupt you, ma'am, but you have last 2 minutes.
Okay, or while simultaneously they show enthusiasm about the game by either giving it a very high rating or strongly recommended it. In conclusion, in this paper, we use game reviews data on Steam websites and divide them into 5 categories to study the differences between these categories. We perform exploratory analysis, sentiment analysis, and topic modeling respectively. We discovered that players or reviews of shooter or FPS and strategy games show slightly more positive sentiments toward these games and spend longer hours playing these than players of other 3 game categories. There are limitations of our paper. We need to study more recent and representative datasets that include a wide range of video games. We also use more advanced sentiment analysis model to explore The planner grants emotions of players, for example, happy, sad, worried. In addition, we can conduct a more deep topic modeling to discover in-depth insights. Thank you for your listening. Is there any questions?
I would like
Sorry.
to, yes. I
Sorry,
have
I
one.
didn't. Oh, okay. Thank you.
Okay, Lynn, my question is, from which nationalities do the your data set, the players come from?
Data set is from US.
So they were from US.
Yes.
Okay, good. And my second question is, you have 79,437 reviews, right, in the sample?
Yeah.
Do you know whether they come from different people, or it could be that one individual has submitted several reviews?
We found that they come from different peoples, but for example, a person maybe play several games, so they have the potential to write several reviews from different game categories.
Okay, good. So thank you very much. Quite an interesting analysis. Thank you.
Thank you.
Thank you, Lynn. Actually, I also want to ask one question. As Galia ma'am has asked about, if you are collecting the data from the people from, they can be from different places. But I think on the basis of the different areas, I think the people are having different reviews and different kind of interest in different games. So how you are going to identify? Have you put any the input? Have you given any input regarding that? That people from different places are going to play. So which kind of data set you have prepared for that? Like you are collecting the data set which should be live, or you are collecting it from the already existing data set?
Sorry, I didn't hear it clearly.
I just want to ask your data set. You are collecting the data set which should be live data set, or you are having any passive data set?
Oh, there's the dataset from the Steam website.
From the website. But I think this is the weak point. I think if you are taking the live data, I think it would be more I think useful, or it would give the better application for the people if we are collecting the data from live areas or the live games. We can collect data from that places also.
Okay, you mean we should find the data from like the whole world?
Yeah.
Oh, okay. Oh, thank you for your suggestions. Yes,
Yeah.
I think we may think it about later. Yeah.
Can you tell me any other weak point of your implementation which you have not covered in your future scope?
It's covered all the reviews.
Okay, there is nothing to discuss. Okay. Okay, thank you. Thank you. We can move on to the next presentation.
Okay, thank you, dear presenter, for your presentation. Now I'd like to invite our next presenter. Next presenter is Jamie, and he's going to present on a hybrid strategy for DOS detection and mitigation on SDL-enabled legal threats.
Hi everyone, I hope everyone can listen to me now. I'm
Yes,
going
can.
to share my screen. Okay, Good morning, everyone. We are going to present our work, which is basically a strategy for network attack detection and mitigation on software-defined networking enabled real scenarios. We are part from Universidad of Antioquia in Medellin, Colombia, and we are part from the investigation group named JITA. So we're going to review these parts in the presentation. We're going to make a quick introduction. After this, we're going to see what other researchers have done in this type of related to this type of work. And then we're going to explain our solutions. And finally, we're going to have a discussion about what we found. First, it's important to talk about DOS and DDoS attacks. DOS and DDoS attacks are basically a case where a perpetrator seeks to generate a disruption on the service that is offered by a particular node. So let me put it here in presentation mode. It's better here. So normally an attacker can infect some machines here. I'm sorry, some machines here, and these machines just generate a lot of requests, just floating this service and generating failure on the service of the server. So the legitimate users cannot access the service. And these kind of attacks are probably the most common type of cyber attacks. And it leads to a lot of service disruption, and millions of users are normally affected for these kinds of attacks. After this, well, software-defined networks is also a relatively new paradigm where you can basically now program the network. Before, you have the control plane, which is the functions which contain the functions that tells what the data plane does. So basically, it holds the logic of the functioning of the network. And the forwarding plane, both you have in the same equipment. Now, SDN proposed the possibility of separating those planes, and both planes can evolve separately. So now network programmers can design and develop their own apps in order to program their desired behavior on the network. So this can be used, the possibility of programming new apps can be used to prevent attacks like the denial of service, but also it adds new point of failure, since you are separating and you're aggregating, you are adding a new point of failure. So you're adding a controller that is in charge of the control plane, and that is a new point of failure. So having this into account, you have the possibility of having DOS attacks, and you have new points of failure in the new SDN architecture. You have to protect more things, and you can use new things to protect the network. So in this kind of solutions, you have two types of solutions. First, you can have intrinsic solutions that focus on SDN components. So for example, they want this kind of solutions seek to protect the components of SDN, for example, the controller or the new network equipments. So it normally includes new models on SDN architectures. And extrinsic solutions are normally based on analyzing the network flows. So these are not part of SDN architecture, but analyze network flows. That means that capture network traffic and extract features of this type of network traffic. And normally they use two kinds of approaches. First one is entropy analysis, that they want to see how to analyze the variability of these features, or you can use machine learning based solutions. And these machine learning based solutions usually based on binary classification. They just try to characterize if a traffic is an attack or is normal traffic. They work normally on imbalanced data sets. Why? Because normal traffic is normally easy to get normal traffic than attack traffic. And they normally try to do an offline classification. So they usually extract the features and they classify these flows offline. So this is obviously a drawback, since the idea of using this type of solution is that you can identify the attack online when it is performed. So we want to propose a combination of both intrinsic and extrinsic solutions, and that's what I'm going to show you. So we propose this solution where we have first, we want to protect the controller, since, as we stated before, is a new point of failure. So in this case, we are tracking all the traffic that it gets to the controller, and we are classifying online this traffic. If this traffic is classified as an attack, then we send the petition through a REST API to the controller in order to block the attack. So if we trace an attack through our flow extractor, then we block this attack. How we do this? We're using a machine learning model based on random forest. We used a data set we generated in our lab, and we tested with a data set that it was published by another university. So this is our first part of the protection. The next part, we want to also protect the hosts connected to our topology using OpenFlow protocol. What is OpenFlow protocol? OpenFlow protocol is the protocol that the controller uses to program the behavior in the controlled switches. So what we are doing is that we modify the OpenFlow switch. We modify the code of the application of the switch, and then we monitor the statistics sent by the switches about the flow they have installed. And after that, we, based also on a machine learning model, we classify these flows. And if the OpenFlow-based classifier classifies a flow like an attack, then we send an instruction to the switch in order to block that type of traffic. And finally, when we said about blocking traffic, we have two strategies of mitigation. We have OpenFlow meters, or we just block the flow. OpenFlow meters, it's an option that we can use to only limit the traffic of a particular flow. So even an attacker is sending an attack, but probably behind that attacker or behind that IP is another type of traffic, then we just can limit and not blocking all the traffic from that source. So we think this is a less aggressive strategy to mitigate the attack. We set an experimental setup, which is a physical setup. Everything we have is real equipment. We have a controller where we use the Ryu OpenFlow controller. We have a switch that is based on OpenVSwitch, and we have several Orange P, which are like single board computers that we use to generate attacks and to generate legitimate traffic. This is the same scenario, but these are both strategies. One strategy where we have the flow dissector, when we trace the attacks to the controller, and the other strategy where we trace the attacks on the hosts. After performing the test and trying our both strategies, we can effectively check that both strategies detect the denial of service attacks and trigger the mitigation strategy. For example, in orange, we have the traffic from the attack, and in blue, we have the legitimate traffic. So we see that when the controller detects the attack traffic is suddenly stopped. And of course, when we use meters, here the traffic is just reduced to the rate we have programmed. We have found that protection using OpenFlow statistics. So the host protection takes more time to detect an attack, but this can be tuned since we can adjust the sampling period for this type of statistics. And as we said, and we stated before, OpenFlow meters represent more moderate strategy since we can limit the rate of a host of a flow. So we don't completely stop the traffic from that host. So finally, well, the thing is that we presented a hybrid solution. We have two functional models. One protects the controller. The idea of this is grouping packets into grouped packets into flows, and extract features from them, applying a machine learning model to classify this type of traffic. The other module uses another type of features that delivers the OpenFlow protocol. And both the strategies rely on OpenFlow protocol to mitigate DOS attacks. So we are taking advantage of the programmability of the network to detect and also to mitigate these type of attacks. This was tested on a real scenario. The idea is to extend this scenario to more complex topologies. We have tried this in emulation. And basically, we adjust our code in order to function with different type of topologies, not as simple as the one we use. And also, this protection strategy can be migrated to other controllers in case you have more than one controller in your architecture. And finally, we're also pursuing to implement a better tune algorithm for both, not only for the OpenFlow-based classifier, but for both classifiers. We have tried different type of algorithms, and we want to also try multi-class classification, not only binary classification when we get attack or normal traffic. Okay, this was financed by the Ibero-American Science and Technology Program. And that was all. I hope you enjoy it. And if you have any questions, I will be pleased to answer it.
I have one question.
Yes.
And namely, it's related to the data set that you were using to train the machine learning model. You've mentioned that it was generated in a laboratory.
Yes. Yes.
Just to provide some more details, because we know that for a successful machine learning model, the training data set is very important, right?
Yes, yes. I was. You're right. I was focusing on the solution. I didn't talk like properly about the data set. Well, the data set consists in about 2 million samples around. Maybe I think 60% of these samples are attack samples from DOS attack. We use different type of tools to generate the denial of service attack. The thing is that it's difficult to get real data of real denial of service attack, like a real attack to, for example, Amazon or some real service, but we have different tools that can emulate these attacks. So we take information from these tools, and we also generate normal traffic. What is normal traffic? Is, for example, when we have a web browsing traffic, file transferring traffic. We have different types of normal traffic. Here we know there is a limitation, and it's a well-known limitation. It's how you define normal traffic, because normal traffic is a lot of things. So it's difficult to find patterns amongst the normal traffic. So what we do is we generate our data set, and we test it with a data set that is published by another university in Canada, which is really a well-known data set. So that's broadly the characteristics of the data set.
Okay, thank you. Meenakshi ma'am, do we have any question?
Yeah, Jimmy, actually, I am really very happy with your work, whatever you have done. If you have implemented it, as you said, you have done it in your lab. So I just want to ask a single question: which classification method you have used here?
Yeah,
Like
we
you
have
are
tried.
saying. Hmm.
We have tried different type of classification methods. With really simple. We have tried SVMs, random forest, decision trees. Basically, that those three were the one we tried. And the best,
Okay.
like the best results we get with random forests, and also in performance because it's it's a really light algorithm, and since we are doing online classification, we are searching for that also. We need to classify an attack fast.
Actually, in your slides, you have not mentioned the comparison of result by using these different algorithms. So I was just a little bit confused how you can say that this algorithm is best, because you have you have not showed any result of these different
Yes.
algorithms, whatever you have applied. I think this is the
Yes,
missing
yes.
part in your PPTs.
Yeah,
You should
you're right.
mention
You're
that.
right.
Even you can mention whatever result you got through your implementation part. I think you should also mention that in your PPTs.
Sure. Yeah, you're totally
This is my
right.
suggestion. This is just suggestion from my side.
Yeah, thank you. Yeah, you're totally right. I will take into account. Thank you very much.
Okay, Jamie, thank you. And yes, Dr. Galia, if you are having any queries, then you can ask.
No, nothing more on my side.
Okay.
Okay, thank you so much. Thank you, dear presenter.
Thank you.
Now, moving for our next presenter. Our next presenter is Pawan Sharma, and he's going to presenting on review of deep learning techniques of chest X-ray analysis for thoracic disorder. Dear presenter, you may please start your presentation.
All right. Yeah, hi, good afternoon. My name is Pawan Sharma, and I'm doing my research at BITS Pilani, Hyderabad campus. This work is carried out under the supervision of Professor Guru Narayanan and Professor Anupma, again from BITS Pilani. My work is based on the review we carried out on the deep learning techniques that are used for chest X-ray analysis, primarily for detection of the thoracic diseases. Now, the motivation behind this research is to answer the fundamental question: can a deep learning based algorithm distinguish between normal and abnormal chest radiograph results that suggest significant thoracic diseases? Thorax is the area between the neck and the abdomen of the body, the heart, the major blood veins, and the lungs. They are all located in the thorax. The thoracic disorders are conditions of the heart, lungs, mediastinum, esophagus, and great vessels, and may include diseases like achalasia, emphysema, fibrosis, lung cancer, etc. The work involves development of a hardware accelerator system running deep learning algorithm that can classify abnormal and abnormal results from chest radiographs with one major thoracic disease, and to validate the algorithm's performance using independent platforms, including CPU, GPU, and the FPGA. So this system is going to act as an aid to the radiologist and may help to improve the diagnostic accuracy, especially in reading the chest radiographs, and can assist in prioritizing the chest radiographs, thereby help the radiologist in improving the efficacy of the system. Now, we will try to answer these fundamental questions as part of this review. So when we start looking at the various machine learning techniques, as a subset of AI, machine learning is the science and the art of programming computers so that they can learn from the data. So this allows the computers the ability to learn without being programmed explicitly. And the machine learning is of great importance, and it can solve a lot of problems for which the existing solutions require a lot of hand tuning and they can solve complex problems for which there is no good solution using the traditional methods. Now, most of the tasks that involve machine learning involve making predictions. So this means that the system needs to be able to learn from a set of training examples and then apply what it has learned to new examples it has never seen before. A good performance measure on the training data is good, but it is not enough. The real goal is to do well on the new instances. So machine learning, this can be put into two groups based on how they generalize, the instance-based learning and the model-based learning. And instance-based learning is like learning by heart, where the system memorizes the examples and then applies them to new cases by using a similarity measure to compare them with the learned examples. The second technique is learning based on the models. Here you can generalize from a set of examples by making a model of them and then making predictions based on that model. Machine learning systems, they can be further put into different groups based on how much and what kind of supervision they get while they are learning. So there are four main types of learning. The first is learning with supervision, learning without supervision, learning with some supervision, and learning with reinforcement. The first three techniques differ in terms of the availability of the labeled data, while the reinforcement learning is different, in which a learning system called an agent can look at its surroundings, choose and carry out the actions, and then get the rewards in return or penalties in the form of negative rewards. And then it has to figure out on its own what the best long-term plan or the policy will be. So the policy will tell the agent what to do when it is in a certain situation. So this deep learning is based on neural networks, which are a subset of machine learning and are sometimes called artificial neural networks. The structure and the names are based on the human brain. I hope this screen is clear, like it's an overlap in the system. I hope that is okay. All right. So yeah, you have an input layer along with one or more hidden layers and an output layer that make up a node layer of ANN. Each node, which is an artificial neuron, is linked to other nodes and has a weight and a threshold. Any node whose output goes over the threshold value is turned on and starts sending data to the next layer of the network, else no data is sent to the next level of the network. For neural networks to learn and get better over the time, they need training data, and this type of neural network is what we call as the feed-forward network, because the information is passed from one layer to the next. Now, people often talk about deep learning and neural networks as if they are the same thing, which can be confusing. So it's important to remember that the deep in deep learning just means the number of layers in a neural network. So there are different kinds of neural networks that are used for different things. You have the convolutional neural networks, which like the feedback networks, but they are usually used for image recognition, pattern recognition, or computer vision. So these networks are using linear algebra concepts, especially the multiplication of matrices, to find the patterns in an image. The second important thing to understand is to reuse what you have learned, meaning the same DL techniques can be used for different types of data or different applications. This is what we call as the transfer learning. To give you an example, imagine that you have to draw a forest with some drawing software, but you can't do copy and paste. Then you would have to draw each branch and leaf on each tree separately, and then this is going to be a very time-consuming task. Now imagine if you could just draw one leaf, copy and paste it to make a branch, then copy and paste that branch to make a tree, and finally copy and paste this tree to make a forest. So you'd be done in no time. So when you analyze the real-world data, it is often organized in a hierarchical way, and your DNN automatically takes advantage of this. The lower hidden layers, they model the low-level structures. Intermediate hidden layers combine these low-level structures to model intermediate level structures. And the highest hidden layers and the output layer combine these intermediate structures to model the high-level structures. So this hierarchical architecture not only helps DNNs get to a good solution faster, but it is also making them easier for them to adapt to new data sets. So the network won't have to learn from scratch all the low-level structures that are common. Instead, it'll only have to learn the higher-level structures. So transfer learning is a very important domain, a very important model for analysis of the chest X-rays. Continuing with other models, we have the image level prediction network that is used to describe the tasks in which a whole chest X-ray image is used to predict category label, which we call as the classification. And in this model, classification and regression, these two tasks are put together because they usually use the same kind of architecture. Then you have image segmentation and localization networks. Then they focus upon breaking up an image into different parts and then figuring out where some anomaly is in a picture. The semantic segmentation model is one where all the pixels that belong to the same type of object, they are put into the same segment. For example, in the vision system of a self-driving car, all pixels that make up an image of a pedestrian could be put into the pedestrian segment. So there would just be one segment containing all the pedestrians. Now, in the context of chest X-ray analysis, segmentation is the process of drawing a line around a lesion or organ and figuring out how much space it takes up based on the image analysis, like pixel intensity or the edge analysis that can be carried out. For example, if a patient has liver metastasis, the lesion segmentation would outline the shape of this metastasis so that the largest diameter in both the long and the short axis could be found. So as with segmentation, the localization is another task that can be used in the medical field to identify parts of the body, the abnormalities or structures which can be made by the foreign objects. One popular mode is the region convolutional neural network that can find the regions of interest in an image and uses a CNN architecture that can help you extract the features from these regions. Image generation networks are equally important and have often been used to make new realistic images based on what the computer has learned from a training data set. There are many reasons to make images in the medical field because of the limitation in the availability of the data sets. So, for example, like these techniques can help you make them easier to understand by increasing the resolution or removing projected structures that get in the way of analysis. So you do some kind of data augmentation and then you can modify that image, or you can make images look like something from a different domain, which we call as the domain adaptation. So researchers, they have used different generative schemes to improve the performance of the tasks. And they try to figure out if something is not right and how they can separate them into different groups. The GANs are especially very popular for the image generation networks. Now, the deep learning relies on large amounts of annotated data. Numerous attempts people have made to do the digitization of the radiological workflows that has helped the institutions to collate and then categorize large sets of digital images. There have been advancements in NLP algorithms that have also helped the techniques so that the reports can now be automatically analyzed to extract the labels of interest for each image. So when we make a selection of the data set, we need to be very careful in understanding what are the features and what are kind of labeling techniques have been used in this data set so that you can use them efficiently for your model.
Sorry to interrupt you, sir, but you have last 2 minutes.
Last 2 minutes, okay.
Yes.
I'll quickly go through this important part where we are focusing upon building an FPGA-based accelerator. So the FPGAs, they are the reprogrammable hardware that is cost-effective and they can be used in almost any hardware prototyping. So this will make the time it takes to get an electronic product, a much shorter time in the market. And they also let you do computations in parallel, which is very important when you need to process, for example, multiple signals, and especially running these compute-intensive algorithms like CNN. So the FPGAs, they support HLS, high-level synthesis, they support HDL codes, and you can make use of these to techniques to run the compute intensive CNN algorithms so that you can run these algorithms to analyze a data set containing the chest X-ray images, and then you can predict what kind of thoracic disorder the person is suffering from. So FPGAs, they can provide more than 10 times the energy delay efficiency. So instead of focusing upon the CPUs and the GPUs, our target is to build a hardware accelerator that can actually help you do the computation much faster than the CPU and the GPUs. So to conclude, the public data sets are available, and we are trying to experiment on 4 data sets to begin with, which are publicly available. And we will try to build the CNN-based models. We are experimenting on AlexNet, DenseNet, ResNet, and a variety of CNN models that we will test. And eventually the target is to build an accelerator. So this automated chest radiograph interpretation is going to be, the future in the medical domain. And we find a lot of medical applications that can make use of this kind of a setup. And this can always be expanded to other different kinds of diseases using the transfer learning and other segmentation techniques. Okay, thank you. I'll stop here.
Okay, ma'am, do we have any question for the presenter?
Yeah, thank you so much, Mr. Pavan. As you have just taken the problem which belongs to the medical side, I think there is so many research which we can do for the medical problems. Right. But I think if we just start anything to do in medical side, I think there should be some medical people. They should be connected with our research. Like if you are concerned, if you are having any doctor which belongs to this field, I think, or if they give some consent for your data set, whatever data set you are using, like if it is publicly available, I think it is the data set, because the publicly available data set which will be the data set from different countries. If we are talking about the India, because you belong to India, so I think there is a different factor. We are having the different kind of as well as the physical problems, whatever the other people like from different countries, the people are having. So I think if you are working on any data set and if it is not live data, I think we can't conclude that in India, which kind of, we can say that the prediction will be. So I just want to say, because I am already, there are so many students which are doing some research in medical side for these kind of problems. But I think there should be one guide or co-guide in your research, which should belong to the medical side, so that if there will be the consent from their side, I think they can conclude that either you are doing in the positive way or the negative way, because right. We are not from this side. We are not from this side. I think there is no doctorate which is basically from this field. So how we can say that this is the probability, or these are the results, whatever you're getting in your research.
Definitely, ma'am. Yes, we are trying to get in touch with some hospitals in India, especially AIMS and SMS.
I think if you should get some live data set, I think you should try onto that data set. I think it would be more appropriate for Indian people as well.
Definitely, ma'am. We'll keep that in mind. Thank you.
Thank you. Yes, Professor Galia, if you are having any query, then you can ask.
Yes, I have one question. It's more a technical understanding question. Which framework have you been using for the calculation? Is it TensorFlow or Keras? Just an example.
We are focusing on TensorFlow right now, but the major focus is on building an accelerator, which is FPGA based.
Okay, good. Thank you.
Yeah, thank you.
And I congratulate you. I find this really a very pioneer work, I sure. should say.
Yes, thank you very much. Thank you.
Okay, so moving for our next presentation. Our next presenter is Alexandra, and she's going to presenting on application of data mining clustering for patterns analysis of cyberbullying surveys.
Harsh, please ask every presenter about the timing of the presentation should be in this period. I
Yes.
think half an hour is left and there are 3 candidates they have to present. So I think
Yes.
it would be better for us to.
Yes. I request you all, please stick to the timeline so we can conclude the session on the time.
Okay, thank you. Can you hear me correctly?
Yes.
Yeah, okay. Okay, thank you, everyone. Hello, I am Alexandra Bermeo, and I am going to present you this paper. Is called Application of Data Mining Clustering for Parents Analysis of Cyberbullying Surveys. So this paper was made in the context of a research project among 3 universities from Ecuador. 2 of them are in Cuenca, and Universidad de La Suaya and Universidad de Cuenca, and one of them was a university from Quito. Okay, so the outline of my presentation will be an introduction, methodology, the results, and finally conclusions. For starters, why we wanted to center on this topic is because we figured out that cyberbullying is one of the most common problems that can be found among teenagers, among kids, and especially in the latest time because of the widespread use of social networks. Then the consequences of cyberbullying can include from anxiety to depression, and in extreme cases, it can even take us to suicide. And all these causes of these consequences obviously are detrimental both for individually and the society. This is why having policies, regulations, and some kind of tools to prevent this problem is a constant challenge for the society. So through the use of data mining techniques, we find relevant patterns and in the behavior and in the answer of in this case, we work with teenagers in the late teens, and also the object is to find patterns and determine the most important questions that we can find from the data that we collected, and we're taking this as a start point for future works. About the methodology that we use, here is a general overview of the use of methodology. This one is based on the CRISP-DM methodology, and we can see that we have the 4 steps: data collection, data pre-processing, the application of clustering techniques, and the evaluation of the model. In the following slides, I will be explaining each one of them. First of all, for the collection of the data, this was made through the application of a questionnaire, of a survey to approximately 120 students, if I am not misled, of Universidad de La Suay and Universidad de Cuenca. We work with the first years, so all the people are, as I was saying before, in the late teens, among 17 to 19 years approximately. This survey had 2 parts. The first one, it included all the sociodemographic information as where do they live, who do they live with, if they live with their parents, if they live by themselves, economical information, family and student information. And a last question was a general question about the psychological well-being of the student. How did the student consider that his well-being was in a scale from 1 to 10? Later was the victimization scale. The scale of victimization among adolescents through the mobile phone and the internet. This is a recognized scale, and the one that we use has already been proved and validated by research groups in Spain and Mexico. It was validated among both groups, and actually from the original scale to the Latin American context, for the validation, we found in a paper that they added 2 extra questions. So this is the first step. For the pre-processing of the data, The first step was to do a cleaning process where we find if there were errors in the records, in the moment of the answer, if the students didn't understand the scale that was asked for them to do, or if they added more characters than the ones that were required. So the first step was to clean. Then in the questions that were actually used for this study, they were for the CIBB-IC scale, for the cyberbullying scale. All the questions, all the answers were from 1 to 4, from 1 being less, if we can say, less bullied or less related with bullying, and 4 is the more often or more according to bullying attitudes. And then the psychological well-being, as I told you, was a scale from 1 to 10. And this scale represent the ideal way for each of the categories. Also, for the well-being scale, we did a normalization to put it on the same scale of the previous one. So we transformed the 1 to 10 to 1 to 4 in order to have it both scales in both questions, and it's part in the same scale. Then the application of the clustering techniques. As we know, clustering is one of the most useful techniques in data science, and is widely used as one of the most important steps in exploratory data analysis. Which was the first step, and the first, with an exploratory analysis, we wanted to figure out the first answers that we could find with the data that we had. These type of algorithms are used to find useful and unidentified patterns by dividing the data into groups of similar objects. So in this case, the objective was to find clusters with answers similar, that will give us an idea of how much bullying or cyberbullying the person was receiving, or in how much danger the person was of being become depressed or have anxiety because of bullying patterns. Also, the K-means algorithm has been widely used and implemented in several domains, and is one of the most used and known clustering algorithms. So therefore is the algorithm that we used to apply the clusters. Now, once the model was defined in the software, the first step was to do an evaluation of the model, to define how many clusters we were going to use. In order to do this, the elbow method was used. And in this method, we have the number of clusters and the distortion score, that is the square of the errors. And the elbow method is the ideal number of clusters that's going to be the most efficient for the data that I'm using, is exactly the place where the elbow is forming. So in this case, is the list of cluster with the list of distortion, that is the name of 4. So we are going to work with 4 clusters. Now, for the results of our paper, first one, we have the centroids of the clusters. And in this image, we can see all the CQ 1, 2, 3, all the way through 8 are the 8 questions that were first of all evaluated in the cyberbullying scale. And we also have the well-being scale. And we can see here the 4 clusters formed. For example, the cluster number 2, that is the green one, we can see that it's really dispersed, and it has answers all over it. And since it has the most high number of answers in some questions, but it has a really low in some others, like it's not the most reliable one. But we have the cluster 0 and cluster 1 in the inside, where we can see that the answers are closer to 0 or to 1, 1.5 at the tops, and all the questions have a similar answers. So it's like more reliable kind of clustering. Then a heat map of each of the clusters that we find. We find that questions 4, 5, and 7. And if you check it against the well-being scale, we can see that they have concordance because the well-being scale is in example, it starts with 1.8 in the cluster 0, and it goes up to 12.4. And if we remember, the scale is from 1 to 4, which means that in cluster 2, we can see that the people is more tend to be in the danger side of they don't feel good with themselves, and they are more prone to be cyberbullying, or actually are receiving cyberbullying. And it's the same, that we can see the same tendency. It goes with question 4 and question 5. For the conclusions and future work that we could figure out, we define that the k-means, the application of the k-means algorithms is the ideal one, because the results allow to locate behavioral patterns among the data that was used. And it is observed that the perceived psychological well-being of each student worsens while the frequency of cyber abuse on mobile devices increases. I guess something that I didn't establish before was that the part of the scale that we use is the one according to cyberbullying through mobile devices, because the other part is cyberbullying through web pages or actually use of a computer. Also, this corroborates what has been previously presented, that is mentioned that there are serious consequences of cyberbullying that can start from isolation and decreased self-esteem, which escalate progressively until reaching limit situations. So the behavioral parent says that as the student presents that it feels the worst, and it is correct, and it has relation with the answers that as it goes closer to 4, it presents that it's receiving more cyberbullying, that it's in more danger of have more serious issues. Also, this process can be applied in future projects focused on cyberbullying, where also it's been planned to expand the study sample, as well as work with more variables in order to contribute to the little that we can do to help to the eradication of this social problem. For future works, we are planning on applying the same questionnaire, but in teenagers of high school level, because according to what our psychologists that collaborate in the project have told us, is in that space where it's most common found the cyberbullying among students. So this work, as I was telling, is from Universidad de la SUAY, and also we have the help from the LIDI, that is the Laboratorio de Investigación. And here are again the authors, my contact, and that's it. I thank you for your time and open to any questions that you may have.
Meenakshi
Yeah,
ma'am, do we
Alex.
have any questions?
Yeah. Yes, Alexandra, I think one question, as you just told us that there are 10 levels you are using for the psychological, there are 10 levels, 10 psychological levels you have used in your paper. Can you just tell me what are these and why you have used just 10 levels? Is there any logic behind them?
For the psychological well-being?
Yeah, you have used 10 level.
Yeah, in the question, we asked for how is you perceive psychological well-being from 1 to 10. Actually, we just put a scale 1 to 10, 1 being in this case the best, 10 being the worst. It was a recommendation from the psychology that works with us, because the other option was to put an even larger questionnaire about well-being with more detailed questions. We one which is actually validated, but the psychology told us that for the kind of study that we wanted to be, and for doing this start of comparisons, it would be good just to ask the student, how are you feeling from 1 to 10? How good are you feeling? And it was actually an arbitrary scale that we chose from 1 to 10.
Okay.
Thank you.
Okay, Dr. Valia, you can ask.
Yes, thank you. My question is related to the definition of the cyberbullying. Are you exploring certain platforms like TikTok or Facebook or WhatsApp, or how do you define cyberbullying?
Well, for this first project, the definition of cyberbullying is any kind of aggression or uh, I don't know the word for bullying. I have it in Spanish in my head, but any kind of aggression or people making fun of you through, in this case, any kind of application through a mobile device, not in anyone in special. We are planning to do it in a further works to try to define which one is the worst, if we can put it in that way. But in this case, it's just through a mobile phone, and the scale that we're using, it actually tells us, it just talks in general about a mobile phone.
Okay, so you haven't asked the participants to specify on which channel exactly?
No, in this one, no. It's just if someone has made willing to use through your cell phone. And we put on examples, any social network, for example, Facebook, TikTok, Instagram, but we put as examples the most common ones for the teenagers in our environment, but we haven't done we don't have the answers like this one is the most used or that kind of data yet.
Okay, good. Thank you.
Thank you.
Okay, thank you.
Okay, thank you, the dear presenter.
Thank you.
Okay, so moving for our next presenter. Our next presenter is Manoj Subhas Kakade, and he's going to presenting on centralized task scheduling on load balancing balancing on a cloudlet.
Good afternoon to one and all. I hope my screen is visible.
Yes, sir, it is visible.
My name is Manoj, and I will be discussing about centralized task scheduling and load balancing on the cloudlet. And I have done this work under the supervision of Professor K.R. Anupama in BITS Pilani KK Birla Goa campus. This is the agenda for the today that we are going to go through. The background of the research is as day in and day out, more and more applications are becoming resource extensive in terms of requiring great processing power, memory requirement, greater deliverability of the battery. We need to send the data to the cloud. And then we need more powerful device for better processing. So in this, the cloudlets are the terms which are being intermediate things between the cloud and the end devices in the picture. So instead of migrating the complete data to the cloud, which is having more latencies, and that we can have cloudlets at the fog level. So instead of accessing the distance cloud, the user can connect to the nearest cloudlet. So the industrial IoT, the target of this research is towards the industrial IoT systems, where all the industrial IoT systems generally go for a remote server or a geographical local private cloud, which is again having a huge cost. So alternative to a private located cloudlet system that provides a similar services than of a cloud-based system, while it will retain more data privacy. So cloudlet will help us to do the processing and computing of the offloaded process from the device in the network. So here we are proposing an architecture wherein industrial systems which are generating the data will be at the bottom layer. They will share the data to the SOCs. In our case, we are terming them as in cloudlet nodes. These SOC will have the capability to process the data and schedule the task locally. And there will be a manager SOC or a centralized coordinator, which will at any given point of time manage the workload of all these SOCs or the cloudlet nodes. And eventually, if they are not able to process the data or the task scheduling is not possible on these nodes, then the manager SOC will eventually route data to the cloud. So in this architecture, we are designing an algorithm for scheduling the task and sharing the data from the edge devices on the cloudlet. So here in each node, that is an SOC-based node in the cloudlet will have information manager will have the following statistics, such as how much percentage utilization of CPU has been done, what are the current application software it has been using, what are the available application software, available data space, and what is the network bandwidth available for setting the connection between the nodes. And any node in the cloudlet system will have 3 states which we have defined or assumed for an algorithm to run. That is in heavy state, where it cannot support further processing of the data. So it will migrate the data to either medium or lightly loaded loads. And these, all the 3 states like heavy, medium, and light, are defined with reference to, again, the CPU load, available data storage, and network bandwidth. So at any given point of time, each node will send its status to the manager SOC, so that the manager SOC will have the statistics about the availability of the task and data with reference to various nodes. And then we will see calculate a formula based on number of tasks completed in the past window, number of tasks which are being executed in the current window, and the number of tasks which are there for a future window, with reference to the amount of time the task required to execute in present, current, and future window. And we are assigning various weights to these numbers so as to see what is the probability of tasks getting scheduled on a particular cloudlet node. And then within thresholding algorithm, we have set a threshold. If n is less than the threshold, then the task may be migrated to a node with having the least n value, so that it will be either medium or low. And if no node is available with less than threshold, then definitely data will go to the cloud. So for this, we have done an experimental setup. We are using Qualcomm Snapdragon 410C board. Out of 5 boards, 1 board will be acting as a manager SOC, and remaining 4 boards will act as a cloudlet nodes. And these are the capabilities of the particular manager SOC nodes, with having the CPU, GPU, memory, and 802.11 support, so that we can connect wirelessly all these nodes. We are implementing this algorithm in programming language is JavaScript, and software platform is Node.js. So while implemented, these are some of the results. We have assumed initially that all the tasks or all the nodes are mediumly loaded, and then we start varying the window size from 0.33% to 0.8, and with reference to 3 weights, we are running the algorithm, keeping the past, current, and future window same. And from this, we have obtained a result for task scheduling. We can see that wherever the results are best for 0.5 for all W1, W2, and W3. And the task migration is more when you have 0.5 things, but that will not be an ideal case scenario which will run on the cloudlet node. So tasks might get varied depending upon the availability of the node, depending upon the network traffic, and so many conditions. So keeping this in the mind, we followed some other algorithm results and kept our present size of this occupancy is 0.4 and past and future window as 0.3. For varying the high threshold and the medium threshold, we varied the high threshold between the CPU being 60% utilized to the 90% utilized, like mediumly loaded to the heavily loaded in the 10 step of 10% more. And then also varied the number of nodes with heavily loaded nodes from 1 to all 4. Like when we loaded with only 1 node is heavily loaded and all the other nodes are ready to accept the task, what will be the result? And when similarly all the nodes gets loaded, then what will be the result? So here you can see that when varying the number of highly loaded nodes from 0.6 to 0.9 or 1 to all the 4 nodes loaded, we can see that when the task or the nodes are heavily loaded, the task migration will get affected because there are no other nodes to migrate the task. All the nodes are heavily loaded. Similarly, when we see that the behavior is better when 80% because of the migrated task can be scheduled, but after 80%, neither the task can be scheduled nor it can be migrated to other node. So only other alternative for that particular task is to go to the cloud. The last experimentation we have done on varying the size of the future and the past window so that we should know what is the probability of the task which can be put on a particular clouded node. And here also we have varied the past and present windows from 10 to 20 in the step of 5. And from this result, we can see that if we know the task scheduling in advance, we will get a better result. So with reference to the future window, we have got a better result while increasing the future window size. So these are some of the outcomes of our particular work, which has been carried out. The centralized multitasking scheduling algorithm is extremely simple and can be easily deployed in the distributed system. Here we have assumed that only 4 clouded nodes are there. We can increase those and then obviously the performance will increase. So task schedulability is 75%. And when we are considering 4 nodes, and we are not considering manager node for implementing the task. If we consider manager node also can implement the task, then the utilization becomes 91.2%. So in any given system, this is a better option to implement a cloudlet rather than sending the complete data to cloud, because your latency will get improved, your privacy will get improved, and you will get results quickly in the industrial IoT solutions. Also, we can conclude from analysis that weight assigned to the history and current and future tasks must be the same. If they get varied, then we get a different threshold. And if we increase the high threshold, most tasks get executed on their own node rather than getting migrated to a different node. Definitely, when we migrate the task from one node to another node, we will have latency in the results. And at the end, if we are able to get more clairvoyant understanding of the future tasks, then we are in a better condition to get a good results. We are going to extend this research by using a heterogeneous network. Right now, we are only using 410C. We are now in the process of generating results with 820C, 833, and more SOCs. So thank you for patient listening, and any questions I can answer now.
Ma'am, do we have any question for present?
Maybe I can pose one question, namely, could you give me an example? Which company could be a service provider for such a cloudlet?
Yeah, ma'am, cloudlets are still not being commercialized. It is still in a very nascent stage. And there is no market player who is providing a cloudlet solution, even though there are some market players which are providing an edge computing solution, but not in cloudlet. So we are trying it with Wi-Fi. Qualcomm is trying with 5G to establish their network. And we are going to take support of Qualcomm to go our research taken further. But as of now, there is no vendor which can provide end-to-end solution in the cloudlet.
So this offers like a business opportunity.
Yeah.
Okay.
And that is why the targeted area is industrial IoT system, because they will not go for global companies, because they are more interested in maintaining the latency and the privacy of the data. So if they go with an commercial service providers like AWS, Microsoft Azure, or other thing, then security might get compromised as well as latency might get compromised.
Okay, I see. Thank you so much. Thank you.
Thank you.
Okay, Manoj, I am also having one question. Can you just give me an example of centralized task, as you have just given the title of the topic is centralized task scheduling. So which kind of task you have considered here?
Centralized task scheduling, the name has been given because ideally the cloudlet should be distributed. Centralized means it will have a single point of failure. And right now, when I am referring, the tasks are being scheduled by my manager SOCs. If you see the bottom layer hierarchy is a normal clouded nodes, and if they are heavily loaded, then they will not be able to schedule the task. So the manager SOC at any given point of time has the knowledge of what are the other clouded nodes, which whether they are able to migrate the task or not. So hence the centralized I'm trying to mean is the manager SOC, where that SOC will be responsible for scheduling the tasks and getting the optimum result in the cloud network and maintaining that network rather than having a completely decentralized thing.
Okay. Okay. Thank you.
Thank you, dear presenter, for your valuable presentation.
Thank you, sir. Thank you.
Okay, now I would like to invite our next presenter, Mohammad Alhani, and he's going to presenting an optimized one max problem by PSO and CSA. Okay, I think so. From his side, no one is here. Okay, so moving for our conclusion for this session. Okay, so to recapitulate this session, I sincerely thank our authors for their excellent presentation and great contribution in this session, and all the participants for being a part of this international conference. We hope on behalf of whole team, thank you for your support during this version and the previous version of this conference, and we will be happy to have you all in the physical mode in the next version of this conference in 2024. And moreover, all the participants will be getting their digital certificates through email within 2 working days, and all the papers have been already forwarded to the Springer. So, and the publication will be live within 5 to 6 months. So kindly cooperate with team ICICT 2023. And just before we end this session, I would like to request, I would like to thank our session chair to chair the session. Okay, just a second. Ma'am, there's one token of appreciation to chair the session on behalf of Global Research Foundation ICICT 2023. Just a second, ma'am. It's a yeah. Yeah, it is. Thank you, Meenakshi ma'am.
Thank
And
you so much, Harsh. Thank you so much, ICICT 2023, for giving me this opportunity. Actually, I am just connected with this conference since last 3 to 4 years. But I think every time it's a very good experience when we just listen the topic or the presentation from different reason of the students. I think it's very good experience when we are having the experience of listening different students from different areas, different countries. Thank you so much,
thank you.
ICICT.
Okay, thank you, ma'am. And Galia ma'am, here is for you.
Thank you. Also, on my side, it was an amazing experience to meet all these colleagues with their exciting research. And I also would like to congratulate you, ICICT 2023, for a great organization. Thank you, sir.
Thank you, ma'am. Thank you. And I once again thank our session chair to chair the session and give their valuable time to us. Now, in the end, I would like to request you all to turn on your camera so we can capture the good memories of this virtual conference. Yes. If it is possible, other participants can turn on their camera. No worries. Okay. Thank you, ma'am, once again, and thank you, dear participants. Just a second, thank you. Thank you all.